Yeah, good morning, everybody. Thank you very much for being part of today's Q&A session where we're going to look at lesson 6 and we're going to dive into soils and the soil mapping and soil tests that you're going to be doing if you haven't already. So let's take a look at the lesson itself, and we will then just review that, and I know we have one question that was put on our Google Doc sheet that's pretty deep question, so we'll just see where this goes today. But I will share screen. All right. Okay, so we're looking at lesson 6, and it's a little bit of an easier lesson from lesson 5 there. So lesson 5 is pretty tricky, and I notice there's still some submissions for lesson 5 that I didn't get around to taking a look at before the holiday break, but I will be doing that today and tomorrow, so no worries. But yeah, it was a bit tricky trying to forecast where water's going to, it's the micro watershed that a lot of people have challenge with, and I totally get that. It took me a while to really get a good handle on that myself. So today's a little bit easier. We're looking at lesson 6, and we are looking at the soil. So there are 3 different components that we're looking at with lesson 6. And the first thing is we're going to look at soil mapping. So the soil mapping for those in the U.S., and I think everybody in this class is from the U.S. You can use the USDA Web Soil Survey, which is actually quite an incredible tool. I know where I live in British Columbia, Canada, we have some really good soil surveys, survey information that's online, but it not quite not quite the depth that the USDA survey has here. So you're very fortunate to have that in the United States. And to use it properly, probably have to go and just take a look at this tutorial here, because there's a couple of important steps you have to take in order to activate what's really called here the area of interest. You have to let let the platform know what the area of interest is, and in order for it to function properly. So if you're not entirely sure of how that works, do take a look at the tutorial here, and it will really help you along there. So you're going to get a description of the soil in your project site area, and these are some of the descriptors we'd like to see in your assignment. Whether it's classified as farmland, all of these items here that are important considerations. So that's pretty straightforward. Now, if you're outside of the US, I don't believe anybody in my group is, but you'd have to look at other resources to get the same information. And in Canada, they're certainly there, but it's going to be touch and go depending on what country you were looking at. And some of the assignments here that you want to consider, some of those elements. Okay, so that's a survey map, and that's pretty straightforward. Let's take a look at one of the previous students' examples here. Now, this student isn't using the USDA site because they are in British Columbia, Canada. But the information shown here is extremely similar. This is more depth than you need to get into, but basically we want to get into soil testing as well. So let us take a look at the next part of the assignment here, which indeed is the soil testing. and it's going to be a jar test. So they are it's a fairly simple way of determining the sand, silt, and clay found in the soils that you're testing. So again, it's basically a free test. It's going to give you some good information. And towards the end of my chat here today, we'll talk about some other ways to test your soils if you wanted to go a little bit further down the rabbit hole with that. Again, there's instructional videos here on how to do this, but it is pretty straightforward. This is Marisha here, one of our instructors, who's put together this video. And you're basically just going to take a mason jar, fill it up maybe halfway with your soil sample, and you're going to shake this all up after you've filled it with water, and then you're going to let it sit. And all of these different particles will settle out. The sand will be the first one, and then the silt, and then the clay will settle on the top of your sample. So again, very useful. And what we're going to do is we're going to ask you to compare this to the mapping. And we'll do that when we get to the narrative analysis. So again, there's some good instructional videos here. There's a little bit about the texture pyramid and the feel of that. So again, there's a lot of resources on the discussion board here. Again, another item we want to do, make sure that you do, is a percolation test, and that is easily done with your test hole. So that's going to give us an idea of two things. It's going to somewhat confirm the texture of your soil. So if you were, say a sandy loam, or you had a lot of sand in your soil, you would expect that percolation to be quite a high level. So it would drain out of the hole quite quickly. And if for some reason it didn't, that's going to be quite a clue for everybody that there is something else going on outside of the soil texture inhibiting water movement. And more often than not, that is compaction. And we see a lot of this compaction with our projects, whether it be in urban areas or even on acreage sites, pastures, paddocks, any areas that have been, well, I'll say any areas that have had trees removed and other things are going on there, where there's been equipment or livestock moving along it. So that, again, is part of this process here. And let's go look at the example. So what we want to do when we get to the testing is have your base plan on the left here, and just indicate where you're taking your samples. And then, of course, a little bit of information on those, the date, why you're choosing that area, the microclimate, vegetation, and if you can place an image here, that's fantastic. So this one sheet tells us quite a bit. And then we're going to go through each individual test. And again, this is a good example where you have the soil texture triangle. You have the image here with a few notes. You have the jar image itself. And I will say this is one of the hardest things to do, is get a really clear image of your jar test. And what you'll probably find is you have to shine some light on it or have it outside. And if you can, do your best at taking that image, because it's the one opportunity I have to try and verify indeed how that texture test has worked out. Because as you can see in this image, you can't see anything. But if that's the way it is, not to worry. It's just the clearer the image, the better. And then we have a ribbon test. And then the percolation test here. So you can see it was kind of a medium fast rate where they were lost 3 inches of water per hour. Funny enough, where I live, probably that hole would probably drain off in about 10 minutes. So I'm on Sandy Loam here, and it's extremely fast infiltration. But all this is really good information. And then when we go to test site number 2 and 3, we're just doing the identical process. We have your jar and images. And here you're showing that indeed you have a 12-inch deep hole and what that soil profile looks like. And then we get to a comparison here where we're going to compare each hole, what the textures were, and then we're going to kind of summarize how this texture is versus what our soil map said. So one kind of caveat there is if you go to the USDA soil texture map and or soil map, and you are in an urban area, it's quite possible that it won't match up. Often when we look at urban areas, there's a lot more sand that's brought in during the construction phase of the house. So quite often we'll see more sand within the testing. So that is a little interesting tidbit. Then we have, a little bit of notes here about some of the limiting factors that we want you to identify, and some notes, and then some local resources to build soil, as well as some of your goals. And then to summarize it a little bit here, and then there's the SWOT analysis. So, what have you taken away from this test that you've gone through? What are the strengths that you're seeing with your soils, the weakness, opportunities, and any threats that it may have? All right. So in this student's example, this is very sandy, not much clay, so not much water holding capacity. And that's really valuable information going forward, because as noted below here, if you want to increase water holding capacity, we're going to be looking at adding organic matter into the soil. And there's a number of ways we can do that. And it also may be a compaction issue. And then we want to think about how we can alleviate that. Right. So let us see. I think we've gone through each step here. And again, there's some excellent resource videos. There's also some resources here on that tab, as well as your rubric. You definitely want to take the look at the rubric and make sure that you've included everything that we've asked for. Because again, this is what I base all my grading on. And yeah, so that gives you a little bit of info there. Let me just take a look at a question we had from Brittany. So it's a really good question, and it's certainly one that has popped up in my mind years ago. So let's there are some aspects of this that have come up with myself. So let's take a look. It's kind of a multi-stepped question here. Okay. So Brittany wants to know whether it's possible to address, basically to get water sinking and slowing down in this climate that is, she's termed sort of a Mediterranean, rainy Mediterranean, where we get most of our rain during the winter months, and then we have periods of summer drought. And that's a great question. So one of the things I must add that Brittany is on a large acreage. So she is looking, I believe it's 100+ acres. Um, and anybody who's not familiar with her site, you could go and take a look at her submissions in well, I guess it would be lesson 5. Get a better idea of her site. It's very interesting because it's like many that I've seen that students have presented as a project site where it's a large acreage and some of it has been logged over the years and there's some water running through it. There's lots of resources that are quite incredible. So if we're looking at trying to hold that water, um, it's going to be somewhat site specific, and your soil test is actually going to play into this a little bit. So if we're looking at smaller acreage and urban sites, often we have far less space to work with, and we still want to have the same strategies where we're trying to hold water as much as possible. So there's a couple things that come up. And one is that if we just raise the percentage of organic matter in our topsoils by 1%, we're going to get about an extra 20,000 gallons of water holding capacity per acre. And that's huge. So in terms of storage, that's one of the low-hanging fruits. Um, in that we don't have to worry about ponds and cisterns to increase the water holding capacity within our site. We can look at the soils and trying to bump up the percentage of organic matter. Now, that also plays into the compaction concerns because you could, in theory, have quite a bit of organic matter, but if the area is compacted, there is going to be a tendency of runoff. So we definitely want to look at that, and that's not part of this lesson in that we're not actually testing compaction, but that infiltration portion of the test does raise some flags for us. If you have a soil texture that's typically going to be fast draining and it's not, then you know there's something else going on. Now, just trying to get back on track here. So soil is the first low-hanging fruit. Let's get into some of the specific questions here about drought proofing and use of swales. So I'm not familiar with all of the content of the course because it does change constantly or be upgraded over time. But I have seen a number of videos with Darren Doherty talking about contours, and I'll try and find one here and post the link for everybody to take a look at. It was fascinating. Gosh, it was a couple of years ago, but I'll take a look at for that link. And basically what it is Darren and there's a few other people involved with the conversation, just discussing the benefits and liabilities with swales. And that's what they were primarily looking at, because as you know, you hear about swales and they're very exciting. And I know when I was first getting into permaculture, I just thought they were an incredible tool and an incredible strategy that one could use. And I still think they are. I've had them. I used to have a swale on my property, and it was very interesting. I don't have it anymore. I've since sort of modified our rain catchment here a little bit, but in this part of the world, they are tricky. So if you have an on-contour swale, and you're going through some atmospheric river events, it's basically going to be fully saturated, and you're going to have overflow, most likely, coming off of that swale that you need to manage. And so that's a big consideration. How are you going to manage that? What's the soil types? If you have, because the whole idea of a swale, it's very much like a rain garden in that you're trying to infiltrate that storm water or roof water and get it into your soils without, prior to it running off the project site. So part of that soils, and part of it is also managing how much goes into that. And I might have time today, but over the last couple months, and I'm sure some of you have seen some of the images I've shown about a very large rain garden that we put in our property here. And that sort of plays into all of this. How much can you infiltrate? How much can you send into these structures? And I think that is part of it. So with any swale or rain garden, one of the key elements here is calculating the runoff that's going to be going into the structure. And let's use rain garden as an example. Let's say typically in an urban setting, we'll be looking at taking water off of a roof surface and putting it into a rain garden. And we want to make sure when we do that, that we have at least 10% of the area within the rain garden. So if we look at the rain garden, say it was 100 square foot flat surface, we then know that we don't want to have more than 1,000 square feet of roof going into that rain garden. If we start breaching that 10% mark, you can get yourself into a little bit of trouble. And those numbers I'm throwing out right now are pretty general. You can dial into a more accurate number with this handbook here. Maybe I won't go there right now. I don't want to get too far off of these questions, but that's basically where you want to be. So if you undersized a swale, so in other words, the supply going in there, it just was exceeded the ability for that soil to absorb it, you are going to end up with quite a bit of a more of a stormwater challenge. How are you going to dry that up now? So yeah, this is tricky. Personally on large acreage or agricultural areas, I would never suggest a swale. That's just my personal opinion, but I would highly recommend a keyline plow or keyline design. And it's very different, a very different approach, but it's similar in that we're trying to infiltrate soil we're trying to infiltrate water into our soils. And we do that by using a pattern that we come to based on the contours of the area. As well, we're using this type of plow, which is an amazing device. And we're very lucky on Vancouver Island where I live in that we have one on Vancouver Island. We've used it a number of times. So the beauty of this plow, as you can see in this image here, is you can run the plow and it will decompact below ground while basically leaving the surface undisturbed. So we're not disturbing tremendously the surface. You can see with this unit, it has a roller on the back. So it's actually sort of trying to push the turf back together. And there are many versions there's another one that has more tines to it and it doesn't have a roller. But long story short, this method will aid water distribution. And the reality of what they're trying to do here is take water that's in a traditionally damp part of the landscape. So if we looked at this is the natural concentration of moisture. Water runs into these gullies or streams or low parts. And we tend to get dry ridges, which are these areas here. So with Keyline, we're trying to take some of this water that's in these damp areas and push them out onto the ridges. That's basically what we're trying to do. And we could be spending a whole lot of time just on Keyline design. I've taken a couple courses on this, and it's yeah, you can go down quite the rabbit hole with this. So if that's one thing you might want to look at, if you are on larger acreage, is trying to get a plow in onto your property to utilize this in terms of distributing water through your site. So you can see that as I'm kind of addressing this question, there's multiple layers to multiple strategies one can use. You know, you want to improve your soil, you want to distribute that water. Okay, so there's a couple of different approaches that one could take there. So yes, there is a risk, I think, in parts of the Pacific Northwest where this could work against you, where you could end up with some very wet ground that becomes tricky to manage in the spring or during the winter months. Let's see here. So let's go to the next part of the question. So off-contour is really, you know, a drainage or conveyance swale. And I have used that in our work on urban sites where you want to kind of try and hit a happy medium where you're moving water, but you want to allow a little bit to infiltrate. But it again, when you start looking at these, this is more of stormwater management. We're trying to move water from one area to another. And with that in mind, we can just kind of back up to what I said before about Keyline. So the Keyline design is almost a passive way of this happening. And yes, swales are passive as well. But the advantage, of course, is when we look at Keyline, it's not a permanent, there's no structure being created here. This is just below ground, some below ground work. So the disadvantage of the swale is it's permanent, and if it's on a large property, it will be a significant cost. Again, I'm not slamming swales. It's just in this part of the world, I'm not sure I would be comfortable moving forward with any of those on larger acreage. Let's see here. So draining, basically, Brittany's asking about draining. Are you actually going to dehydrate this? Yeah, that is definitely a risk. There is a very fine line between drainage and infiltration and rehydration. So again, this is very site specific, and a little bit of a tricky one to answer. Again, where I live, we have so much infiltration. You know, we're sending thousands of, when we have a rain event, we're sending thousands of gallons into our rain garden, and it basically disappears. And the way our property is set up, it's ideal because we have our rain garden at the top of a slope, so everything downhill from that is going to benefit. Well, that's our theory anyways. We should have a huge amount of water holding capacity downhill, so that's going to help during the drier months that during the growing season. A couple other parts of the question here. So on contour brush pile, that's a wonderful idea. And I would even go a little bit further and say you could look at on contour hugelkultur. I'm sure most of you have heard that. probably spelling it wrong here, but hugelkultur is an amazing process where you're using wood um, underground to help retain moisture and slow down. There's a good example of it. This is probably a little extreme, the slope here, but again, this is a nice cross section of what's we're trying to achieve. And there are so many versions of this, from quite small to quite large. So again, you could use hugelkultur in a urban area. You can also use it on a very large acreage. So you may be on a site that has been previously logged and you have a lot of woody debris. And that's one way that you could deal with it. You, in fact, are going to end up building soil with it. And that way, all the wood is covered and is touching soil. So again, it's not a fire hazard. And keyline. So we touched on that. And Brittany's asking with keyline, how's that handled by high rainfall events? You know, that is certainly worth a lot of consideration. And I think to answer your question, Brittany, you really don't want to look for a silver bullet. You want to look for a multiple layered approach to, this sort of a challenge. So you don't want one single thing. I wouldn't suggest anywhere just coming in and doing a keyline design and plowing to improve soil and water distribution. It's a big part of it, but you have all these other items you want to take a look at, decompacting, adding, increasing the amount of organic matter in the soil, which will in turn raise the carbon levels up within the soil itself. You could use, another thing I could touch on is biochar. That is something that could be incorporated into soils as well. It will increase, it's not a new tool by any means, but you hear mixed results that some people have had with it. I think in this part of the world, it is really useful in a number of ways of reducing wildfire potential by taking some of that debris and turning it into a stable carbon. But there are, I think, some best practices with that. You have to ideally inoculate it with a compost for a number of months and then apply it after that. Okay, I just see I have a couple of questions here, so sorry. James has a question. Does the type of wood used in a hugel matter? Well, in my experience, no, it really doesn't. What I would suggest in the Pacific Northwest is to try and avoid woods like Western red cedar. And the only reason is that it tends to have compounds within it that are rot resistant, and it will take longer to rot. Now, if that's primarily what you have available, then go for it. I would say it's almost more important when we get into some of the smaller branches, because you don't want, any green material. You certainly wouldn't want green cedar material in there. So when we've built hugelkulturs, we've used alder, fir, maple as the primary woods. And when we put together planters, I can just show you something here. My wife offers a service where she helps people grow veggies, and this is kind of our version of building a planter. It's kind of a hybrid hugelkultur where we're filling the base of a planter with woody debris, and in this case, it looks like alder. And then we backfill on top of that with just 100% compost that we've made, primarily out of wood chips. And the results of this type of planter are simply amazing. So does it matter what type of wood? Largely no, but do just be a little bit cautious of cedar. And yeah, biochar, pretty cool. Let me just see if I can find this link. That's super interesting. There we go. So we're considering buying this biochar kiln. And it's not an easy thing to do in Canada because we have, a different currency and duties, etc., and shipping. But this is an amazing product. If take a look at it, it's wilsonbiochar.com, and she's got some really interesting videos here. And this is a unit that breaks down and is portable. And we're looking at this because in our community, we have a lot of people that are burning brush. And I don't like, well, I'll back up a little bit. Yeah, we have a lot of brush burning in our community. And I think that, there's a better way of doing this where we have cleaner air and we get a yield out of it. And the yield being biochar that we can add to composts and soils, and it is a stable carbon source. So I believe with biochar, they're capturing about 50% of the carbon. So that's great environmentally. And yeah, this is a great little page with lots of resources if you want to check it out. I quite like this kiln. I know one of our instructors, Dow Orion, she has this as well, but I think she has a previous version that's slightly smaller. As you can see, it's not low cost, but there are, many ways you can achieve the same thing. I'm looking at this from a point of view to use it within the community and have some fairly large burns. You can put in about 5 cubic yards, and I believe you get about 2 cubic yards of biochar from it, and which is huge. So the other part of the question here, James, Douglas fir slash piles. Yes. So Douglas fir slash piles, depending on how much you have, you could look at a kiln, about getting biochar from that. You could also look at using that in, in a hugelkultur mound. So I've seen farms, I guess I've seen agricultural lands. So a lot of British Columbia is zoned agricultural and not, it's actually forested. So I've seen some areas that have had some trees cleared, and they have basically built, one property in particular built a hugelkultur mound around the perimeter with some of the slash. So it was very, very interesting what they did with it. So in fact, they're just taking that and basically building soil with it. And then of course it's not going to be a threat during the summer months. So James, we're using those kilns. Excellent. Some of it's too big. Well, I would say when you're getting into larger wood, that's, you're looking at firewood. And where I live, firewood is incredibly valuable. A lot of people do burn it. and incredibly expensive here now too. We're getting over $300 a cord. That's 300 Canadian, so that's probably 230 American. So yeah, pretty expensive. You might want to consider that if you're getting an abundance of large wood. And yeah, so it's a lots of great tools to apply to your soils. Just want to make sure that I have answered Brittany's questions. I will type in an answer here for the class and for her. All right, now I guess that's the end of our lesson 6 review here. Does anybody have any questions or comments regarding this lesson at all? Let me just, okay. You have a question? Sure. Go ahead, Anna Karen. You can unmute yourself too if you wish, whatever you prefer. And
Yeah,
maybe
my question is in the document. It's about the jar test.
In the document.
Yeah.
Yeah, I'll just wait for you to put your question together.
Oh, it's already in there. Yeah, where the picture is. It's underneath Brittany's.
Yeah, I'm not sure which document. Maybe it is the question document here.
Yeah, in that one. It's right underneath Brittany's questions.
Yeah, I'm sorry, Anna Karen. I can't hear you if you're speaking right now, but that may be an issue on my end.
It's
just
underneath.
Checking my audio here. I think I had my volume down. Anna Karen, do you mind?
Can you hear me?
Yes, I can. Sorry, I had my rookie mistake here, eh? There, you go ahead.
Okay. Yeah, so my question is underneath Brittany's questions in the document. You can see the picture of the jar test.
Ah, sorry. I did not see that. Very sorry about that. Okay, so yours is about your soil test. Does the clay content start at the blue line? Let me just zoom in on this a little bit. That's a good photo, by the way. Thank you. So if I was, best call on this would be, let me get my, sorry, I was just looking for a tool here. This bottom section, I would think is sand. I think right here, this little band, I would say that's silt. And then this top band is clay. Does that make sense?
Yeah, because it's
a lot of sand.
It is, but I thought because that's from my I think that's from my mature forest soil test, and I thought that the whole brown, like all of it, like the majority was silt, and then clay was on the top, and that sand was like there was very low content of it, but because when I look at it, I don't see that many big particles of sand. I guess it's just.
Let's take a closer look here. So you're thinking your sand is right here.
Yeah.
Okay. And then this is silt.
Yes.
And then this is almost no man's land between silt and clay.
I guess. Yeah, because because this jar, I think it's been sitting for 2 weeks now. And
yeah.
The top 2 layers, it did take a while to settle, especially the top one, which is clay. So yeah, I'm guessing it's just there's different sizes of silt, and then just the top layer is clay.
What did your soil have you done your soil triangle texture yet?
Yes. So for both, if I did either or, it would they would be just on the sandy loam.
Right, right. Yeah,
Yeah,
that's a
but
really good question. I must admit I don't think I've seen a jar test that had those distinct, it's either a distinct difference between the silt,
mhm,
but you're saying that the top two layers took a long time to settle out. So I
yeah,
think I would go with what you've suggested here, that the blue line and above are clay, and yeah, go with that.
okay.
Yeah.
So for clay, is there different types of colors, or is it just like what does the color say anything about the type of soil?
It can. Often when I've seen clay in jar tests, it resembles this top layer that you've got. So it's kind of tan colored, right? Light brown. The layer below is more reminiscent of silts, but
Mhm.
it without seeing the jar, it's hard to say. And does it really matter that we're a few percentage different? Probably not, but this looks very, very fine.
Yeah.
So I think it's pretty safe to consider that to be clay. That's how I would go with it.
Okay.
So you're bang on with that. So good for you.
Okay.
Yeah.
Would it be okay to leave both results on the
Would it be okay to
on the
use
website?
both results?
Yeah, just on the triangle, put both of the red dots.
I would
Or
lean, I would just pick one.
okay.
And if you, to the best of your knowledge, this looks like that top layer is clay, but it's kind of separated a little bit. I would just go with that. Sure.
Okay.
Just
Thank you.
pick one and run with it. And it's really not going to make a profound difference one way or the other,
Mhm.
because I think what you'll find is at the you know, end of the exercise, if you're reading other students' reports, and whether someone has a high level of clay or a high level of sand, or funny enough, our strategies are extremely similar. Organic matter and compost are the magic solutions. Not no, not so magic, but they are the ways that we're looking at building soil. And the where it will make a difference is what sort of water harvesting strategies that you could employ. So if you have a lot of clay, and let's say I can't remember whether your site is acreage or urban, um, but that might play into how you manage the water. So if it's a lot of clay and you're on an urban site, and let's say you did want to create a rain garden, you have to be careful that your soils are going to allow for the infiltration. Otherwise, you're in essence creating a pond, right?
Yeah, that makes sense. Thank you.
Okay, sure. Yeah, sorry I missed that, but I will again. I'm going to update this and type all the question answers in at the end of today's talk, just so this is a record that we can reflect back on. Um, yeah, is there any other questions at all from anybody? And if we've got about 6 minutes left here. If there's something outside of this lesson you want to chat about, I'm totally open to that too. All right, so I guess we're all good, and that's great. That's great. Okay. Well, maybe we will just wrap it up, and we'll look forward to seeing everybody's assignments next week. And great to have everybody back, and look forward to the second half of the course here. So Thank you, everyone, for joining me today, and have a great rest of your week.